So when we talk about solar, we think about photovoltaics. We talk about photovoltaics today. We think about concentrating solar power. We talk about concentrating solar power. There is another area where there is a lot of work, and that's in these so-called photoelectrochemical cells. So photo from light, electrochemical because you have an electrochemical processes. And the idea of these electrochemical cells is that you can generate hydrogen by using sunlight and an electrolyte. In this case, you will use plain water. A cell is built very simply. You have a metal, and then you have an oxide. And these are examples of the oxides that you can use. You can use strontium titanate, potassium tantalum oxide, titanium oxide, tin dioxide, iron oxide. This is just plain rust. And if you get a circuit in an electrolyte like that, because of quantum mechanics, again, this is all about quantum mechanics, these oxides can absorb certain wavelengths of the spectrum. And by doing that, you can generate hydrogen. The hydrogen can be stored, okay, or it can be used as a fuel. So this is one of the big questions about hydrogen. Hydrogen could be a fuel. I show you the reaction between oxygen and water. If you have an engine and you combine hydrogen and oxygen, you're going to generate a lot of energy, okay? So you can actually combust hydrogen to produce water. So hydrogen can be used as a fuel, okay? In fact, there are some engines that you can modify. Instead of burning diesel or natural gas, you can inject hydrogen, and it's a very explosive reaction, and you can produce a lot. I mean, this is how rockets go to the to outer space. A rocket is a combination of hydrogen and oxygen, and the amount of energy in that reaction is just astronomical. So you can use hydrogen as a fuel. But hydrogen can be used also as a way to store energy. And the whole idea here is that that's precisely what you can do. Now, once you have hydrogen, the question is, what do you do with hydrogen? As I mentioned, you can burn it, or you can run it through a fuel cell, for example. And we'll talk about fuel cells here in a minute to generate electricity. Now, one of the questions is, what are the best ways to produce hydrogen? Well, I just show you the photoelectrochemical cells. These are fairly good. The efficiency of this process is not the best, but at least the fuel to drive the reaction is free. So this is the great advantage about the sun. The sun is always going to be shining, so if you can take advantage of that, you can get this system going. But in the US, we did a study a few years ago, and we look at different ways to produce hydrogen. And obviously, when you were in high school, you probably did the experiment with electrolysis. You can have a glass of water, you put 2 electrodes, pass an electric current, and you can separate hydrogen from oxygen. How much energy do you have to put? Remember that reaction that we had for hydrogen and water? So if you have plus energy, if you want to go from H2O to, you have to add energy here, okay? And that experiment that you did in high school, if you have water and you have 2 electrons and you pass a current, you can get hydrogen and you can get oxygen, okay? And the amount of energy that you have to provide here is given by this equation. So this is what we call electrolysis, okay? Electrolysis is the process by which you can separate hydrogen and oxygen from water. But it takes some energy, okay? Now, we ask the question, are there ways to generate hydrogen that would require less energy than electrolysis? And the answer is yes. And that's the whole idea behind this program. This was a national program. And this is what we call a high-temperature electrolysis plant. Now, this plant requires a nuclear reactor, okay? So this is where things get complicated. But this is part of a national program where we wanted to start replacing the fleet of nuclear reactors in the US. We have 100 reactors. They are getting old. We need to replace them. And somebody says, why don't we build these gas-cooled reactors? And we talk about that on Monday. These reactors are going to be much safer. They're going to be more efficient than the light water reactors. And these reactors will have to operate at very high temperature. These reactors will use helium as the working medium. okay? Because helium has very good thermal properties. And this helium will be running through the reactor, will get very hot. It will run through a gas turbine, move it, okay? And then generate electricity, and that electricity will be sent to the grid. And then we could condense the helium, compress it, pass it back. There will be another heat exchanger here, and we'll be doing this. But there will be so much heat coming out of this reactor that in addition to moving helium through the turbine, we could actually move helium through a heat exchanger and then use that heat to produce hydrogen. Okay, that was the whole idea. So these reactors will produce so much energy that in addition to electricity, that was the main objective, the excess energy in form of heat could be used for the production of hydrogen. And this is the reaction that people identify. This is today the most energy efficient reaction to produce hydrogen. Okay? We know that electrolysis works well, and we know how much energy we need to apply to water to dissociate hydrogen from oxygen. In this case, they found that using this reaction is called the iodine-sulfur reaction. You can feed water, and you can produce a lot of hydrogen, a lot of oxygen, but you will need some very high temperatures to drive the reaction. So the idea of this national program for the 4th generation of nuclear power plants was to have these reactors that will be working at a very high temperature. These are called very high temperature reactors. They will produce electricity, but then you will take the heat to drive this reaction. And these reactions will generate both hydrogen and oxygen. Now, the problem of this is that these are very nasty chemicals. I mean, if you have worked in the lab with sulfuric acid, okay, you have acids that contain iodine. And, I mean, these things are nasty. These can really eat through metals, okay? And this became a real challenge. Unfortunately, funding for this program was terminated, and they never demonstrated this in a larger scale. But in a smaller scale, they found that this is actually a very energy efficient way to produce hydrogen by taking waste heat from the nuclear reactor, okay? And people did the thermodynamics and the chemistry, and indeed, energetically, this is a very good way of doing that. The other important consideration is that you can do this in bigger scale, okay? So you could have your reactor. Your reactor will be 1,000 megawatts, a gigawatt power reactor. And then you will have so much heat that next to the reactor, you will have this plant making hydrogen. So one of the things that people had envisioned was to have a nuclear reactor, okay? And this reactor will produce electricity. And then you will take the excess heat of the reactor, and you will go through this chemical reactor. And inside this chemical reactor, you will be doing this, okay? And then as a result of that, you will produce hydrogen, and that hydrogen will be distributed. And then one day could be distributed to a fueling station where you will have a car with a fuel cell, and then you will charge that car using hydrogen that was actually produced from a nuclear reactor. This was the big vision for this program. This is back in around the year 2004, 2005. Now, so this was one approach, and obviously the US is such a big country that we just cannot rely on big reactors. We'll have also to rely on some other sources of hydrogen. And the approach was to use wind turbines. And we were talking about ways to store energy when the wind doesn't blow. So you can have batteries, or you could produce hydrogen. Even if you use conventional electrolysis, you could produce hydrogen taking the excess energy of the wind turbines when they are blowing, generate hydrogen, and use that as a way to store energy, okay, whenever the wind is not blowing. And that hydrogen could be used with a fuel cell to produce electricity, or it could be sent through a distribution system, again, to provide hydrogen to fuel your cars, okay? Do you remember that chart that I showed you from General Motors about the future of transport? You guys were not here on Monday, but do you remember how we had the future of transportation GM talking about improvements in the internal combustion engine, hybrid cars, plug-in hybrids, electric cars, and then hydrogen fuel cell cars? That is the ultimate goal of auto manufacturers, whether it's GM or Toyota. They see fuel cell cars as the future. And this is a way that you could provide hydrogen for this system. And by the way, this is the clean way of doing that. Now, you can also produce hydrogen from something called steam reforming. You can react CH4 with water So you can have a reaction where you have methane, which is natural gas, that's 4, 6. Let's see here. So is that right? It's 2. This is 4, 8. This is 4. Okay, this process is called steam reforming. So with the steam reforming, you take natural gas, which is methane, combine it with the steam, and you have hydrogen. The bad news is that you also produce carbon dioxide, okay? So the third version that people had for producing hydrogen was to use a fossil fuel power plant that would be running on methane, for example. But then a requirement will be to have carbon capture and sequestration. So that's where this CO2 sequestration will come into the picture. By doing that, then you don't have any emissions into the environment. You will produce hydrogen according to this steam reforming reaction. You can produce also electricity, and then you will distribute your hydrogen into your refueling stations. You know, this is the big vision that people have to distribute, to produce and distribute the hydrogen in the system. Yeah, and this is not good, okay? This is not good. It is not good because we produce carbon dioxide. But the reason why people use this process is that we have a lot of natural gas. And in fact, there are some demonstration projects in California right now. And BMW has one of those demonstration programs. They install a few refueling stations around Los Angeles, and most of the hydrogen is being produced according to this reaction. Now, that's changing because people are looking at this alternative where you want to use renewables to produce hydrogen. In that case, your footprint is going to be. You're going to change it? Okay. Okay, wait. No. Right now, there is a plant. It was built in Illinois. There's one in Texas where they're doing carbon capture and sequestration. So these are just still at the demonstration level. And it's expensive. You know, it's going to take some energy to do the carbon capture. And that's the problem that, you know, nobody wants to pay for it. So the only way you're really going to force people to do this is if you put a tax on carbon. You know, once you put a tax on carbon, then people are going to be forced to do it, and there's just no question about it. And then the question is, do you pay the tax on carbon by doing this, or do you build windmills and photovoltaics and concentrated solar? And people are going to realize that, you know, once you put things on an even level, especially with solar, that this is going to be really the way of the future. So.
But the thing is that in a near future, it's not possible to.
Yeah, it takes a lot of, I mean, these are big decisions. The US, you know, we're like in a transition mode right now because people, when President Obama was elected, everybody thought that we were going to have a carbon tax. And in fact, Al Gore used to be the vice president of the US, and he has been very outspoken when it comes to climate change. And Al Gore had actually proposed, it's not a carbon tax, but it's an exchange system where you can buy credits. So if you want to do this, you say, I want to pay, and somebody installing these systems can buy my credits. And then it will probably do the same effect. And unfortunately, the US, that didn't happen. In Europe, I think they have an exchange system for carbon. So yeah, that's a problem. But this is currently the most common way to produce hydrogen these days. Ready? Uno, dos, tres. Okay. Very good. So this is this is a future vision for how hydrogen could be distributed. Again, this is under the premise that the future of transportation is going to be with hydrogen, which I think in the case of the US is going to be true. A large fraction in 25, 30 years, a large fraction of the fleet is going to use fuel cells for transportation. Now, this is one of the most beautiful concepts that you will ever find, okay? And these are called super cables. And if you remember the energy flow diagram that we talk about a lot on Monday, on the left, you have your sources of energy, and then you move to the right. And if you remember, the way we produce electricity is a very inefficient way. There are lots of losses. We lose a lot of energy because of frictional losses in the system, joule heating on the cables. So somebody came up with an idea, said, why don't we use superconducting cables to transmit all the electricity that we need in the country, okay? With superconductivity, there are no losses. Electrons flow without any resistance, so there will be no losses. Obviously, you have to provide energy to the system to be superconducting. And the way you do it is by cooling down the cables. So depending on the transition temperature, there are some high-temperature superconductors that at 80 Kelvin, they are superconducting. And somebody said, why don't we develop these super cables? And these super cables are going to have this architecture. Inside, they're going to be hollow, okay? So they're going to be like a pipe, hollow. And in that pipe, we are going to be flowing hydrogen. And we're going to liquefy the hydrogen. So we're going to cool down the hydrogen to make it liquid, okay? And then we're going to have these pumps, and we're going to be pumping liquid hydrogen inside these pipes. Now, if the hydrogen is in a liquid state, it's going to be very cold, okay? And what they were saying is that because it's going to be so cold, then we can introduce a superconducting cable that will transmit electricity. So by cooling down the hydrogen, you provide a low temperature so that this superconducting cable can transmit electricity without any friction. So somebody was saying, if this is really going to be the way it's going to be, then why don't we install these super cables instead of pipes? And by the way, the electricity that is produced by the nuclear reactor has to be sent to the cities, to the people. So we're going to transmit electricity using these superconducting cables. And then inside, we're going to be transmitting hydrogen to distribute to the system. So this was one of the, in my opinion, this is one of the most beautiful ideas that you will ever think about, these super cables. Obviously, it's still a concept, but this will be a way by which you could transfer both electricity and hydrogen at the same time, and you take advantage of the need to cool down the cables to make this phase superconducting. So again, this is a concept, but this could be a way by which we could make this system operational. One of the problems with hydrogen is that you need special technologies to, yeah.
It is not used because to flow the hydrogen. It's liquid, because if you want to do it in all the cables, all the power plants.
It will be a major investment. You need special pumps to move hydrogen in a liquid. Your insulation has to be very good to prevent it from heating. So it will require a big investment. Now, the question is, somebody needs to sit down. In fact, the people who came up with this concept, they did a calculation. They say, okay, right now we waste 60% of the energy because of losses. So what if we do this? The losses are going to go down. It's going to cost some money to do this. But at the end of the day, you know, if you can install these for so many miles, you still are going to be coming ahead, even though it's going to be very expensive. Your loss, instead of being 60%, are going to be 10%, and then the benefit is going to take care of itself. So, so the merit of this concept is the fact that you will overcome a lot of the losses that are already existing into the system. But you're right, it will be very expensive. I mean, pumps to move hydrogen are very expensive. Now, those pumps exist. If you think about the space shuttle, you know, the space shuttle uses two solid rocket boosters, but inside there is in the middle there is a big tank. That big tank has liquid hydrogen and liquid oxygen, and then there are some pumps, and those pumps move the gases into the three main engines of the space shuttle. So those pumps already exist. They are very effective. They could be built. It will be very expensive, but I think the benefit will be there because the losses will be much lower. And that's, you know, again, economics. All these things, you know, we talk about science and technology, but also the economic factors will come into the picture. Okay?